So the next section is troubleshooting VASP. So whenever problems occur, as they do from time to time, there are several different steps that you want to take to troubleshoot. And I want to go through the most common problems and the steps that one would take to fix them. The very most common issue that I see as a consultant when looking at VASP jobs that have failed is the issue of hanging due to either bad CPU or bad GPU task binding. And this can be caused by either running on hyperthreads, which overcommits the CPU cores, or by using a GPU binding other than GPU binding equals none. Or if you run the wrong number of MPI ranks on a GPU node, this can also cause this issue. A second issue that typically only affects new users is if you try to launch your script and it says VASP standard not found, then this is usually a sign that your license hasn't been confirmed and you haven't been added to the file group to access VASP. So the way to solve this is to just fill out the VASP license confirmation form and then wait until you're added. Out of memory is another thing that we see frequently for large jobs. And the way to solve this is usually to increase the number of nodes and GPUs that you're using. And this spreads the size of your job over more resources. And then you can just increase this until you get the job to fit into memory. Another type of failure is catastrophic failures, such as segmentation faults or MPI errors. And these were more common with earlier versions of VASP, such as VASP 5, than they are in the newer versions. And they also occasionally occur in versions of VASP that have been compiled with plugins. And the reason is that VASP, as they've continued to improve the code, have added a lot of checks and ways to trap problems with solvers before they cause an actual catastrophic error. So more often if you did something that causes the solver trouble, such as placing atoms that are too close together, then you'll typically now get a real error message rather than one of these. But if you're using an earlier version of VASP, this is something to look out for. Another thing that can happen is if you are porting your input files, such as your POSCAR files, from a different machine where they were made with Microsoft DOS, then VASP may fail to read your files due to seeing inline characters. So the solution to this is just to remove the inline characters in your input files. Finally, keep in mind that from time to time, there are intermittent issues with either bad nodes or the file system or the communication network that happen on a large system such as Perlmutter. So occasionally jobs will fail for reasons that are no fault of the users. And then once these issues are fixed, the job should run normally. So as far as troubleshooting tips and tricks, I have several of these that I found to be very helpful. The first thing is to always check the JavaScript and your NCAR and your POSCAR for mistakes that you made before submitting the job. It turns out that many of the issues, for instance, with binding and issues that cause hang, can be fixed in the JavaScript without even changing your input files at all. And then to look for diagnostic issues, I recommend checking the outcar and also both the standard out and the standard error files. And what I like to do is to set up my script with these statements, where these SBatch statements that generate a uniquely identified standard out and standard error for each job, so you know exactly which job failed in which way, and you can see both the output and the error message. Another thing that occasionally happens when jobs fail is that if you have a job that stops before the buffer that prints to the standard out is full, then you may have a message that doesn't get printed to output. So what I recommend doing in this case is if you add the stdbuf output equals L tag to your job, as shown here, then this means that if an error message is thrown to standard out, it'll automatically be piped to the output file, even if the job fails. So sometimes error messages that were hidden will suddenly become manifest if you add this flag to your job. Some other things that can be useful are increasing the number of resources if you suspect you're running out of memory, or also running either a different VASP module on Perlmutter, or switching between either the CPU or GPU builds if you're running one versus the other, just to see if the error is inherent to your job or if it seems to be dependent on whether CPUs or GPUs are being used. Another thing you can do is, if your job appears to be hanging, is you can SSH to the node that's running the job, and you can use the top command to see the CPU and memory activity of your job. And if you are running on GPU nodes, you can use the NVIDIA-SMI command, which will show you the GPU activity. And finally, I also recommend, if you have a job that hangs for some inexplicable reason, is to try repeating the job on different nodes, as occasionally there are bad nodes or outages that occur. And one thing you might look at if you find that jobs suddenly start failing is, if you check the NERSC message of the day page, then this has live updates of any outages that are occurring or any situations where NERSC is degraded. If you need resources for troubleshooting, then the place I recommend starting is first with the NERSC troubleshooting guide, which is at the NERSC VASP page. And this has a drop-down menu of the most common errors that occur and then the solutions. Usually, if you see a VASP-generated error message, such as "I refuse to continue with this sick job," then this is an indication that there's something you can probably fix in your NCAR or your POSCAR file that will fix the job. So if you don't see your error listed in this list, another place that I recommend looking is checking the VASP user forums that are made by the VASP developers themselves, as these have a lot of useful advice for errors that can happen, due to the way that you run the code. And also, there is a page of VASP known issues or bugs that are in the process of being fixed that you can check as well. Finally, if you're attempting to troubleshooting a job and you're stuck, you can file a support ticket with NERSC, and we'll look at your job and then try to troubleshoot it. And if you do this, then it helps NERSC if you describe your issue in as much detail as possible, including the error message and the steps that you use to try to fix the job. And when doing this, it's usually not necessary to attach any files. Instead, you can just provide the path to the job of where it is running on Perlmutter, and then NERSC staff can go and look at it in its context directly, and then copy it if needed to reproduce the error.